Uh, Very good morning. This is Surajit Dey, an assistant professor in the Department of Data Science of India Institute of Technology. Today, I am going to discuss on the topic of stack and data structure, and these are the topics that we covered today. This is the introduction to stack, operations and functions of stack, stack implementations, common applications of stack, advantages of using a stack, and limitations and considerations of the stacks. So what is stack actually basically? Uh, uh, the stack is a linear data structure that follows the last in first out principle. So that means, as you know that the data structure can be in two types: the linear data structure and non-linear data structure. So as the properties of the linear data structures, all the elements are stored and processed in sequentially, like one after another. So as we know that stack is a linear data structure. So that means in the stack all the elements are stored in sequentially, and that follows the principle of last in first out, that the elements which are inserted in last positions will be the first element to be removed from the stack. So that is, it is called the last in first out, and it is a collection of elements where the additions and removal of elements occur only at one end, called the top of the stack, right? So that is the restrictions of the stack. So you cannot remove or add elements from and to the stack here, in addition to the top positions. And the top element is the only element that is accessible at any given time. So this is the operations and functions of the stack. So basically, in using the stack, we can implement the three basic operations. The first one is push operations, second one is pop operations, and third one is peek operations. Now, in the push operations, what you do actually, we add an element to the top of the stack, right? So push operations means you are adding an element to the stack, and the pop operation means you are removing an element from the stack, right? And the peek operation means it returns the value of the top element, so without removing it. So that means it shows the value, it shows the element which is pointing by the top positions. The stack implementations. So how can we implement the stack, right? So what are the ways by which you can implement the stack? So basically the stack can be implemented in basically two ways actually: an array, and second one is linked list. So array means what? Array means a set of elements that you can uh, hold in sequentially, and the top element will be pointed by a variable, and just call it top of the stack. And the linked list, using the linked list means you have a certain number of nodes, you can see, and for each node we have the two types of two parts, right, within a single node. One is data part and another is address part. So in the data part, actually it contains the value itself, and the address part means it contains the address of another node. But the node cannot be stored in sequential. It might be in sequential or might not be in sequential, right? And so these are the two ways we can implement the stack, and this is the pictorial representations of the stack. So you can see that the first the figure, you can see the figure one where no elements are there. So basically the top is pointing to the zero position, means it's empty positions when nothing is there. Now in figure 2 you can see the disk 1 has been inserted. So how? The first, before the insertions, what you have to do, you have to increment the top position to 1. After that the disk 1 will be inserted into the stack. And in the third figure, you can see that if you want to insert another disk 2, so for that what you have to do, you have to increment the value of top to its next positions, which is true. And after that, you can insert the disk number 2. In the same way, again, you have to increment the value of top to 3, and then you can insert the disk 3. Now, if I now from that case, now if I want to remove an element from the stack, so what you have to do, the disk 1 or disk 2 or disk 3, which element is going to be removed? So obviously the answer is disk 3, because disk 3 is the last element which is inserted into the stack. So that is why disk 3 will be popped out from the stack. And now after popping out or after removing the disk 3, what you have to do, you have to decrement the positions of the top to next positions, which is the 2 positions. Next means the before positions, right? In top 2 positions. In that way, now in that case, you can see the figure 6. If I want to insert another disk, which is 4, so for that what you have to do, you have to increment the value of top to its next positions, which is 3. After that, disk 4 will be inserted. In the same way, again, if I want to insert the disk 5, so again what you have to do, you have to increment the top value to its next positions, which is 4, and after that disk 5 will be inserted. Now if I want to remove the disk 5, so for that the disk 5, first you remove the disk 5 from the stack, then you decrement the value of top uh, to its previous positions, which is 3. Again, if I want to remove an element, the X4 will be popped out and top value will be decremented to second positions. Right? In that way, if I want to remove the second disk, again the top value will be decremented to 1 positions, and disk 2 will be removed uh, from the stack. So in that way, the operations will be carried out in the stack. So these are the common applications of stack. So basically the functions called stack. So basically when we have a number of calls are there, right? Like suppose we are going to implement the factorial of a given numbers, right? So if I if we use the recursive functions, then it calls again and again until it reaches your uh, the reaching point or object point. So n number of calls are there. So for each call, what you have to do, you have to store each and every call to the stack, right? So that you can reverse in that directions as well. The expressions evaluation, suppose you have given infix expressions, right? So now what you do, if you want to convert it into the postfix expressions, so for that you need a stack, right, for storing all the elements of operators. So and in undo and redo functionalities case also, for undo doing the undo and redo operations, you need the stack element. So these are the pictorial representations of how to insert and how to remove. So you can see whenever you want to add something to the stack, the pop push operations will be called, and whenever you want to remove an element from the stack, the pop operations will be called. Now, advantages of using stack. So basically stack is very simple and easy to implement. So no more complexity is there, and that is also if your stack implementation is efficient, right? So like implementing the post operations or pop operations or peak operations, and it also provides controllable memory management, so with automatic delocations of memory. And so in that way, you can remove an element from the pop operation. So you can initially the stack with the 5 elements are there, A, B, C, D, E. So now top pointing to the topmost element, which is E. Now if I want to remove an element, the E will be removed. And after removing E, top will be decremented to its previous positions, which is the B positions. Right? In that way, the pop operations has been carried out. The limitations and considerations. So limitation means stack is as if we implement the stack with the help of an array. So as the properties of an array, right, prior to use an array, you have to fix the size of an array. So that is the same concept. In the same way, before you use an use the stack, you have to fix the size of the stack. So right, so stack size is fixed and can cause an overflow if it is exceeded, right? If you cross the limit, if you cross the boundary, so then the overflow conditions will be generated. And the lack of flexibility, the elements can also be can only be accessed from the top, so so that it restricting the other positions and operations as well. And stack memory management, in some cases manual memory management may be required to adjust your element, right? So in the last summary, we can recall those concepts that stack is a fundamental data structure that follows the LIFO principles. It supports push, pop, and pick operations for efficient element manipulations. Stack implementations can be done using an arrays and libraries, so with their respective advantages and considerations. So thank you very much from my side.